Hello everyone. So this is my attempt to explain more complicated isomers. So let's do a little more complicated saturated hydrocarbons. So just to review, drawing the carbons first and hydrogens later. So if this is 1, 2, 3, 4, 5, 6 carbons, it should be C6H14 because it's double plus 2. You're saturated. Okay, so it's 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so those bonds should have hydrogens. And let's say I want to make an isomer of this. So again, you move a carbon towards the middle. So let's say I move this one here, okay, towards the middle. This one's gone now, and that's supposed to be there. So let's draw it again. Color. So I just have that 5-chain carbon. 1, 2, 3, 4, 5. And I put it on the second carbon on the left side. And then again, it should still have 14 hydrogens. So just make sure you count it. 1, 2, 3, 4. It only needs 1, right? Because it already has 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So that's C6H14 also. And this is an isomer, sorry about that. So this would be 6 carbons, so there's a hex, and if it's all saturated, it's A and E, so it's hexane, right? So it could be an isomer of hexane, it could be this. So now how do you name this? Okay, so the second carbon on the left side has 1 carbon coming off of it, so it's 2. And then how many carbons coming off of it? If it's just 1, 2-methyl. Right? Then if you remember the last video, what's the longest chain? The longest chain is 5. It should be 2-methyl pentane. Okay, so that's one isomer of hexane. And I just want to give you another example really quick so you guys can see this. So if I still have my 6 going across, it's hexane still, but you can make these pretty complicated. And again, this should be 14 hydrogens, so that should be, let me clean that up a little bit. It's a little crazy. So this goes here, and it should still be, and not should still be, but it still is hexane. So I can move even these 2 carbons towards like the middle of a chain. So I could do this, and it's still correct as long as you have the same amount of carbon atoms and the same amount of hydrogen atoms. So I have 4 carbon chain, and I'm going to move, so I'm going to move this one all the way to this, I'll move it towards this middle, right? Just to emphasize a point that can be labeled right to left and left to right. So I should still have 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, what is the name of this? Okay, so it's on the third carbon on the left side, but it's on the second carbon going right to left. So use the lowest number. And how many carbons are coming off of it? It's 2 carbon chain. So this would be 2, and not methyl anymore, because methyl is only 1 carbon. It's 2 ethyl now. So it's 2 ethyl for 2 carbons, and now it'll be 2 ethyl and butane, right? So the longest chain is 4. So the isomer is also 2 ethyl butane. Hey, I'm hoping you get the idea for a single chain carbons. Just move any of the atoms towards the middle. As long as the structure is different, it will be an isomer, okay? So now let's try unsaturated hydrocarbons, so alkenes and alkynes, okay? Why are they unsaturated? Because they don't have the maximum amount of hydrogens. Okay, they have less than the maximum amount of hydrogens. So let's do something simple first. Let's do pentene, right? So pent is 5 carbons, And if it's E and E, it's a double bond. So I'm going to do double bond on this carbon here. Let's make this a double bond. So if it's an alkene and it's pentene, it should be C5 and exactly double 200. So it should be C5H10. So make sure you drew it correctly by counting the hydrogens. So there should be 3 here, should be 2 here. This one's missing 1, this one's missing 1, and this one's missing 3. So is that 10 hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, this is correct. Okay. So if I want to make this an isomer, let me see if I can do all that. If I want to make this an isomer, it's actually a lot easier with the unsaturated. All you gotta do is move the bond. So the question is, what's the name of this? So yes, this is pentene, but this is known as 2-pentene because, yes, going this way, it would be 3-pentene. But again, the label left to right and right to left. So this is also 2-pentene because the second carbon on the right side has a double bond. Right, it's in between the second and third carbon, but use the lowest number. Right, so if I wanted to make this an isomer, I could just move the double bond. So that should be correct. Draw 5 carbons again. 1, 2, 3, 4, 5. And then if I put the double bond here, now it's just 1-pentene. So yes, that is isomer. And let me show you exactly why. Because not all the carbon atoms have the exact amount of hydrogens also. So this one still has 3. So this one and this one are still exactly the same, right? Because these have 3 hydrogens. So that's correct so far. So this is the same and this is the same. This one has 2 hydrogens. So far, these are not isomers because the first 2 are the same. This one has 2 hydrogens. Oh, but this one only has 1. So it's one area where they're different. Okay, so this one has 2 hydrogens, so that's 1. This one here only has 1 hydrogen. This one here only has 1 hydrogen. So this part, they're the same. But at the end, this one has 3 hydrogens, and this one only needs 2. Okay, but they're both still C5H10. Okay, so the exact drawing is not the same, but they have the same amount of carbon atoms, the same amount of hydrogen atoms. Okay, let's try something with triple bond. Okay, so let's do let's do heptine, right? So it's 3 carbons, 4, 5, 6, 7. Right? So if it was like this, it'd be saturated, but if I'm trying to do an alkyne, I should have a triple bond somewhere. So let's put it let's put it right here. It doesn't really matter actually. Let's put it over here. Okay, so if I were to draw this correctly, right, if I have 7 hydrogens, 7 carbons, I should have less than double minus 2, right? So double double 7 is 14, minus 2 is 12. So let's see if that actually happens. 1, 2, 3, 4, 5, 6, 7. This one has 1 on the left, this one's good, and 3 on the right. This one has 2 on the left, 1 on the right, so that one's good. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is accurate, C7H12. But what's the name of this, right? So is it 4-heptine, right? Because on the 4th carbon here, or is it 3-heptine? So I'm going this direction. So I go this direction, it's 4-heptine. But again, you want to use the lowest number and label it right to left. So to get the lowest numbers, it'll be 3-heptine, because if you count from the right side, you'll get the triple bond between the 3rd and 4th carbon, right? So an isomer of 3-heptine could be 2-heptine, it could be 1-heptine. So if I had the triple bond here, it would be 2-heptine. If I had the first carbon, it'd be 1-heptine. Another way of making an isomer of this, if you really want to get complicated, is I could even move a single bond over. So that's a little more complicated, right? So let's see if that makes sense. Let me draw the carbons again. So what would happen if I were to take this carbon here and move it here, right? So let's see, what would that be? All right, so let's draw so first draw the 6 carbons, 1, 2, 3, 4, and then that has a triple bond. Right, this one here, the triple bond, and then that's the 5th one. It was 1, 2, 3, 4, 5, 6. See, one more. All right, we're moving this one to the 3rd carbon. All right. So what would be the name of this? So let's make sure it's actually an isomer. So let's make sure we first have the 12 hydrogens. So put the hydrogens in. So 1 hydrogen here, 2 there, 3 there, 4, 5. I'm not writing in the hydrogens. It's not wrong if you don't write them in. Just keep in mind that I'm just, for the sake of time, just putting the bond, right? So there's 3 hydrogens there. There's 4, 5, 6. This is complete. That's complete. 7, 8, 9, 10, 11, 12. Okay. So this is still C7H12, but what would you name this? Okay. So first you want to name, and you'll actually never get something that's complicated on the regions. But first name the carbon coming off the longest chain. So this would be, or first to include that, right? So it's going to be a methyl group. And actually, this is a more complicated thought. And the way you number these when you have multiple, I guess, substitutions is you name it with the triple bond first. So this is 6. This would be, actually, hold on, I got this. This is 4 methyl. This is kind of crazy. 4 methyl. And you'll never get something this complicated. I just want you to understand why it's 4 methyl. So it's 4 methyl 2, 3, 4, 5, 6. 6 is hex, so it's hexine. Okay, so this looks really, really complicated. The only thing that's hard about this, or harder, is that you have to remember that if I'm numbering it, 1, 2, 3, 4, 5, 6, right? The second carbon has a triple bond, so that's why it's 2 hexine, right? If I were to leave this by itself, this wasn't even here. If I were to erase this, it'd be 2 hexine, correct? Because there's a triple bond in the second carbon and there's only 6 carbons, right? But if I were to add that methyl group, can I redo this? So now it'd be 4 methyl 2 hexine because the 4th carbon has 1 carbon coming off of it, and that is isomer. Alternatively, an easy way of drawing an isomer of this would just be to move the triple bond, and that's most likely what you're going to get on the regions. Okay, so on the regions, you won't get something that complicated. You won't get a carbon, well, a substituted hydrocarbon that's unsaturated on the regions. Okay, on the regions, you'll get something like this. So what's the isomer of 3-heptine? You could just do 2-heptine. So if I were to go left to right this time, I would have 7 carbons. This 1, 2, 3, 4, 5, 6, 7 carbons. And if I put the triple bond here, right? So if I put it here, this would now be 2-heptine, right? But just make sure that's 100% accurate, that you have the exact amount of carbons and hydrogens. So again, it should be C7H12. Okay, so 1, 2, 3. This one's good. That one's good. 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So on the regions, you'll get something like this. So what's the isomer of 3-heptine? It would just be 2-heptine. So I'm hoping that you see that as long as you're following the steps, that carbon has 4 bonds and 4 bonds only, hydrogen has 1 bond, and that you keep the same amount of atoms, you will have an isomer. Okay. So I hope that helps for more complicated versions, and thank you for watching.